folks, welcome back to example 5. So we're going to take a look at a rational inequality. The upside is I've already got the right side of my equality at 0, so I don't have to subtract anything or collect or add and subtract fractions and simplify. But what I am going to do, I'm definitely going to factor this denominator and use any factoring method you want, right? The AC method, guess and check, those little X's people make, whatever you feel most comfortable with. For me, I'm just going to do guess and check because I need two numbers that multiply to 15, or I should say multiply technically to negative 15 and add to negative 2. And that's going to be 3 and 5. Or really, it's going to be negative 3 and 5. But let's go ahead and factor out the denominator. So if I have x squared minus 2x minus 15, if I were to set that equal to 0, I could factor this into x minus 5 and x plus 3, right? And then when I do that, I'm going to get either x minus 5 is 0 or x plus 3 is 0, right? So I'm going to wind up with these two values of x equaling 5 and negative 3. And in theory, we should also set the numerator to 0, but the numerator is a constant, right? So if I was trying to set the numerator to 0, well, 5 it doesn't equal 0, so I don't get any additional x coordinates that I'm ultimately going to want to put on my sign pattern. Nothing comes of that. So now that I have these two x coordinates, respectively, negative 3 and 5, or the way I wrote them, 5 and negative 3, I'm going to go ahead and make my sign pattern. So I'm going to go ahead, make a little number line here, and then I'm going to properly label everything. So let's go ahead, make our x-axis, or I should say our smushed xy axis. So when I smush that here, I'm going to have x's on the bottom, x, and then I'm going to make the signs for this rational expression. So this is 5 over x squared minus 2x minus 15. And the two interesting x values were negative 3 and 5. And these, I'm both going to, for both of them, when x is negative 3, the denominator zeroes out, so ultimately that fraction does not exist. And also when x is 5, this fraction zeroes out, I should say, excuse me, this denominator zeroes out, so the fraction does not exist, right? So from here, what I can do is I can make my signs, and I've talked about this a couple of times. You can always use test points, so you could pick something like 6 here, plug it in to this rational expression, see if it's positive or negative, and take note. Right? I would pick 0 if I was going to pick a test point in here, plug it into this rational expression, see if it's positive or negative. And the same thing on this last interval, this leftmost interval. But for me personally, I'm gonna use, like I've been mentioning the past few examples, kind of a shortcut, or just once you do enough of these, you start to literally, you see a pattern in your sign patterns. So if I look at the lead coefficients here, I'm basically looking at 5 over x squared, and this is secretly 1, right? Because I have a unsaid 1 out here. So if I look at just the coefficients of the lead terms, it's a positive number, so I'm going to have a lead positive. And then if I think about these factors that are on this denominator, right, x minus 5 and x plus 3, they're both raised to an odd degree. And we've just learned that when you're dealing with sign patterns, if you work around a value of x that comes from a factor whose degree is odd, the sign is going to alternate. So since 5 came from x minus 5, and this has an odd exponent up here, it's going to alternate. Negative 3 comes from x plus 3, it's got an odd exponent, it's going to alternate sign. So that's just a different way of getting that this was plus minus plus, but I also could have plugged in test points and figured that out. But for my endgame answer, I'm looking for where this thing is greater than 0, so I want to find the plus signs. So I can see one here, and I can see one here. I want this interval, the leftmost interval. I don't want the middle interval. And then I want the rightmost interval. And keep in mind, these start at negative infinity and go to infinity. So my answers are ultimately negative infinity to negative 3, and then 5 to infinity. And there's a couple of reasons I have parentheses. I mean, the first thing is that this is strictly greater than instead of greater than or equal to, so I would use parentheses. But even if this had been greater than or equal to, Because these two values don't exist, I still would have had to use parentheses. Those DNEs outweigh any symbol that's going to be here because we can't include anything that doesn't exist. We can't include it in our answer. It just doesn't exist. All right. Thanks so much. Bye.